Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com. It's time for Twit's annual audience survey, and we want to hear from you. Please visit twit.tv/survey and let us know what you think. It only takes a few minutes, and your anonymous feedback will help us make Twit even better. We thank you so much for your continued support. twit.tv/survey.
This episode of Coding 101 is brought to you by lynda.com, the online learning platform with over 3,000 on-demand video courses to help you strengthen your business, technology, and creative skills. For a free 10-day trial, visit lynda.com/C101. That's LYNDA.com/C101. Today, it's time to sort. Coding 101 is next. Welcome to Coding 101. It's the show where we let you into the wonderful world of the Code Monkey / Code Warrior. I'm Father Robert Ballecer, the digital Jesuit. And joining me is our super special guest co-host, Mr. Lou Maresca. That's right, a lead software developer from Microsoft. Lou, thank you very much for coming back on to be our guest host.
Thank you for having me again. I love that. I love that title, super special co-host.
We had to come up with something that actually made sense in the doc, but yeah, it does stick. You are a super special guest co-host.
Yeah. Love it.
Now, you may notice that I am not in my normal spot. Normally, I'm over in Radio Corner. We're going to start shaking things up a little bit in Coding 101. You may have noticed that we're starting to bring you a variety of topics, including things that cross over into hardware. Well, that's not the only format change you're going to see. We want to bring you the same good content, but with more guests and even more explodey things. Well, let's get straight to it. Lou, you've got an interesting story here that you queued up for us to start off with, and it kind of runs on some of the sentiment that came out of last week's episode of Coding 101. There were people who were defending JavaScript. They're saying, wait a minute, JavaScript gets a bad rap. And that got us thinking, yeah, there are a lot of different languages that get bad raps as either insecure or too hard or too easy or too easy to mess up. You actually took a look at which languages are good at what.
Yeah, there's a lot of different interesting articles out there the last couple of weeks around, how safe is this language? How safe? And it's kind of an interesting topic if you think about it, because you can really write almost in any language, you can pretty much write a bunch of insecure code. I mean, any language allows you to be, especially if you have access to low-level functions in an operating system, you can be a menace. It doesn't matter, if you write it in, Ruby or Perl or C# or C++, you can pretty much be a menace in any type of environment. Right. And this article specifically points out things like Perl, PHP, and Ruby.
Why is it, though? I mean, because we've all heard it. Everyone picks on JavaScript, and they all say the same thing, which is, well, the sooner that JavaScript dies, the better the internet will be. Or JavaScript is a natural language for people who want to program poorly. And as you pointed out very quickly, any language can be used to write bad code. So why is it that certain languages seem to be the focus of ire?
I mean, I think one is because there's a lot more people using things like JavaScript. If you think about it, like, for instance, Node.js is one of those big buzzwords that are running around the web right now, is people using Node.js all over the place. And that's pretty much coded in JavaScript. And if you do things like, a lot of things that are pointed out in the article, if you're doing things like you're getting data from users and you're not, like you like to say, is sanitizing your data before you put it in your database, you could be, injecting code or data into your database that could be, cause vulnerabilities to your system. And, these types of things, when you're coding in JavaScript, and a lot of people are coding in JavaScript, they like to kind of put the button on JavaScript, because that's really what people are using nowadays.
Bad programmers are bad programmers no matter what language they're using. But let's talk specifically about Perl, PHP, and Ruby. What's the general consensus about how easy is it to make code that can be exploited?
So I think with Perl, so that Perl creator Larry Wall was talking in this article about he really feels that Perl is a very safe language. He feels like there's not much you can do. There's not many. There's memory management in the language, and there's not really much that you can do to kind of cause issues. But again, he also points out that again, you can pretty much in any language do BMS if you again put data and brought bad data in your database or not sanitize data that's coming in or that kind of thing. And then in the PHP sense, again, PHP doesn't really allow you to do your own memory management. But again, it also can cause problems if you don't sanitize your data. But in PHP's case, there was actually a vulnerability just recently called the Ghost, dubbed the Ghost. And it was a system level call that you were allowed to make from PHP that calls what they call buffer overflow in your memory. And that can actually cause applications to crash. It can cause your machine to blue screen in some operating systems. So it's actually a bad vulnerability. So again, that language normally dubbed pretty safe as a language because it doesn't have access to operating systems and low-level functions actually can cause a big problem.
Right. And Ruby,
then there's also... Yep, go ahead.
I'm sorry. Ruby is interesting when you compare it to other languages. First of all, it's relatively new when you compare it to Perl or to PHP. But also, one of the things I've always liked about Ruby, this is the very first thing I heard, was that it actually does boundary checks before it accesses memory, which it's one of those things where you wonder why didn't every language do that? I mean, doesn't it make sense that before you access, before you write, before you do anything with memory, you would check to make sure that there's nothing in there that's active? And that's what Ruby does.
Exactly. I think the kind of the key to Ruby, especially is some of these newer languages, they use a virtual machine to run them. So like, for instance, C# will run in what we call the CLR, which is the Common Language Runtime. And Ruby has its own VM. A lot of these Java runs its own Java virtual machine. So I think these virtual machines allow you not to have to worry about memory management. And then when you do some low-level functioning, because some of these languages allow you to do low-level type things in the operating system. And what they do allow you to do, and especially in Ruby's case, is like you said, it does check boundaries and buffer and prevents buffer overflows. So which is a big security risk in things like browsers and that kind of thing. So I think it's all dependent on whatever language you're in. I mean, some languages are more risky than others. Like if you're in assembly, I could probably crash your machine in 30 seconds in assembly. I mean, less than that, right? I mean, but with C++, the same thing, because you have low-level access to things that can really cause craziness in your machine. But I love this quote in this article. It says, "The seductive power of any new language is an assurance. It will provide better, faster, and more inherently insecure or secure solutions," right? So it's really seductive to say, hey, well, I really want to try this new language because it could be faster and it could be better, but you don't really know if it's secure or not, right? You don't really know if they've really kind of put that at the top of the stack as a priority. So just be careful with every language you're using and just really kind of understand how you're using it.
Yeah, that's absolutely true. I mean, the way that you get people to switch away from a language is to tell them it's insecure or, wow, that's just slow. Yeah, the way it handles instructions is just ridiculous. It doesn't communicate properly with low-level hardware. And the way that you sell a language is to say, oh, this is so much better because of X feature. And X feature was the one thing that was wrong with Y language. Now, I got to ask you, as a person you do this day in and day out, you are a programmer, you watch other people program, you guide teams as they head into projects. What do you look for when you choose languages for different projects? Because you've mentioned several times on the show that it's not like you stick to one language. You don't write everything in C#. You will use the best language for any given project. So how do you decide?
Yeah, I mean, I'll give you an example. Like, for instance, I wanted to create an app that worked across platforms like iOS, Android, Windows Store, that kind of thing. And so what I decided to choose was I chose to build the app in HTML5 and JavaScript. But then in order to get myself into the stores, into these native stores, I built what we call a native shim, meaning I just built a little kind of wrapper that's built in like Swift or Java, and then it just hosted just a web browser control, and then inside the control I would render this HTML5 app that made it look like a native app, and then this way I could really kind of use the same app code across different platforms. And it was helpful, but then I found out that it actually causes some performance problems because sometimes HTML5 and rendering and browsers are slow and they have problems. So there's really, it's all in a learning aspect, right? You choose it based off of your needs. So if you wanted to get to market really fast with an app, that's a really good way of doing it because you can get across all these different platforms really quickly by doing something like that. But then you run into other problems like performance problems and JavaScript issues and all these different types of things. So again, it's all dependent on your need. Now, if you're just doing a desktop app, sometimes it's a little easier if you want to build an app quickly is to use a managed language like C# or any of these other ones like Python, and it gets you there much faster, right? So I think it's all dependent on the need at the point. But again, no matter what language you're using, you still have to really understand how you're using it and how you're handling the data that's coming through the system.
Fantastic. And, thank you again for bringing us that perspective from someone who's actively involved in the field. Now, when we come back, we're doing something a little bit different. We want to, every once in a while, along with our wildcard episodes where we interview people in the industry, we want to do a couple of episodes that brings back basic knowledge, things that we may take for granted. Now, this often comes from the Google Plus group. It comes from suggestions that I get on Twitter. It comes from people who may visit and say, you know what, I really wish you would cover hexadecimal to decimal change or something like that. Things that maybe we don't think about because we just don't want to do that. So we're going to be bringing Patrick Delahunty, a fan favorite of the show, back on to talk about sorting. But before we do that, let's take a moment to thank the sponsor of this episode of Coding 101, and it's Lynda. Now, what is Lynda, you may be asking yourself? Well, Lynda is a repository for knowledge on the internet. I think that's really the best way that I can put it. When you think about learning, when you think about going somewhere for reference, when you think about one place where you can either renew your skills, learn new ones, or maybe just remind yourself of some of the things that you've forgotten, lynda.com is the place to go on the internet. It's for problem solvers. It's for the curious. It's for people who want to make things happen. And I know that's you because you're watching Coding 101. You're watching shows on Twit that teach you new knowledge. Well, if you are a new knowledge kind of guy, you're also a Lynda person. Maybe you want to master Excel. Maybe you want to learn negotiation tactics. Maybe you want to build a website or boost your Photoshop skills. Well, lynda.com has everything you need to feed your curious mind. Some of the courses that I recommend are localization for developers, HTML essential training. It's actually HTML is one of those primary pieces of coding knowledge that we kind of poo-poo, but there's a lot of people who are interested. And if you're embarrassed to ask your experienced programmer friend, or if you don't want to just go all over the internet, jump into Lynda and take one of their HTML courses and never again be afraid to look at source. You could also take jQuery Essential Training and Code Clinic, which is an innovative monthly series where lynda.com issues a code challenge and authors share their solutions using a variety of different programming languages. Now, we use lynda.com here, not for our programmers, but for our editors. You see, we did a big switch over where we moved from the Mac to the PC, from Final Cut Pro to Adobe Premiere, and lynda.com is the reference point. Anytime they need to figure out how to make something work in Premiere that used to work in Final Cut, they can use the searchable transcripts and find the exact spot in a training video that will tell them how to do that one simple trick that they need. You could watch and learn from top experts who are passionate about teaching. You can stream thousands of video courses on demand and learn on your own schedule. And we're all busy. That's really what we've got to do. You can browse each course transcript to follow along. You can take notes as you go and refer to them later. You can download tutorials and watch them on the go, including access on your iOS or Android devices. The best part is it lets you create and save playlists of courses that you want to watch, which means you can customize your learning experience. Lynda.com lets you learn the way you need to learn. So here's what we want you to do. We want you to try lynda.com. Your lynda.com membership gives you unlimited access to training on hundreds of topics, all for one flat rate. Whether you're looking to become an expert, you're passionate about a hobby, or you just want to learn something new, I want you to visit lynda.com/C101 and sign up for your free 10-day trial. That's lynda.com/C101. And we thank Lynda for their support of Coding 101. Let's get back to the magic. We welcome to the show, or actually back to the show, a now married Mr. Patrick Delahanty. Patrick, wow, that's some bling. Careful, you're going to blind the audience here. So first of all, congratulations.
Thank you.
I think it's every coder's dream to know marriage.
Yeah, and it can happen for you. Oh, great. Sorry, let me block that. There we go.
There we go. Now, sir, you are here to bring us some foundational knowledge. And actually, we got this idea from the chat room. We got this from Steve Gibson, who said, let's learn some of the concepts that go underneath the high-level languages that we're learning or the hardware that we're playing with. And one of these basic concepts is this idea of sorting. Now, for the people who are at home and they're scribbling down notes, what is sorting and why is it important?
Well, sorting is when you have a list of items and you want to put it into an order. So, for example, you may have a list of names and you want them in alphabetical order, or you've got a list of numbers and you want them in numerical order. And so this is how you would get that list. It's all jumbled, and then put it in the order you want.
Right, and this, this is actually something that we covered in a very early module in C#. It was Shannon and I at the time, and we were showing how you could take memory cells that had different numbers, different integer values, and you could use a very simple algorithm to repeat over and over again until everything was sorted out. And actually, if you look through the history of computer science, there have been many different theories as to the most efficient way to sort a random list of numbers. In fact, let me ask Lou about that. Lou, I know there's a lot of automated features. Every language has some sort of sorting feature, but some of the most hardcore programmers I know still take it upon themselves to write more efficient ways to sort any sort of data. Are you one of those?
Yeah, I mean, it really all depends on the type of data you're using too. Like, I know a lot of people that have, maybe they have some numerical numbers or something like they want to do some pixel generation or sorting of pixels or something like that. They actually might write it in assembly because it is a lot faster to do it like that. So you don't have like these big memory managers that are in like C# or Java kind of getting in the way of doing things really quickly. So I think it all depends again on the type of data that you're trying to sort. If it's like large objects, like let's say an object representing a library book, well, then it might be okay to say, okay, let's build a function in Ruby or C# or something like that, and use some of the internal storage algorithms that are already there to be able to sort it.
Right, and to be clear, we're talking about any sort of data. It doesn't have to be numbers. It could be anything that you need to sort, but you just have to figure out how you want to sort it. Now, Patrick, I am assuming that we're going to start with some sort of small demonstration, yes?
Yeah. And there's one sorting method that everybody learns in computer science. It's the bubble sort. And you can do this in any language. And so we're not focusing on any specific language here. We're just talking about the concept. And a bubble sort, its simplest fashion, it compares two numbers. You've got let's say this is an array. We've got values 2, 1, 4, 3. It compares the first two or 1, which is more. And in this case, 2 is greater, so we reverse these. And then our list becomes 1, 2, 4, 3. We move on to the next position, compared 2 and 4. That stays the same. Move on to this last position, 4 and 3. We reverse those. So now we've got 1, 2, 3, 4. And 4 is locked in because this is the last position. It's locked in as the highest number. And then we have to go back through and do it for the first 3 and then do it again for the first 2. And so you have to do multiple iterations of this. I can do a demo here. I've got playing cards. So let's say we've got a random order here. We've got 8, 7, 10, 4, 3. So the first 2, we've got, flip those because 7 is less than 8. 8 and 10, that's correct. We'll switch these around, 4 and 10, and then we've got 3 and 10. So 10 is now locked in as the highest number. Then we start over, 7 and 8, that's correct. 8 and 4, we move 4 down. 8 and 3, and that's locked in. Then we do the same thing. And now we've got just 4 and 3, and so there. That's how a bubble sort would work.
Of course, for something like that, you need to do as many sorts as elements you have in that array minus 1. That doesn't sound all that efficient, really.
It's not the most efficient method, that's for sure. But it is a very basic method that everybody learns, and it's easy to understand for sure.
Right. And actually, if you want to see a code example of how the bubble sort works, go back to Module 1 of Coding 101. We're using C#, and we actually give you a way to program that algorithm. Again, not efficient, but very easy to understand because you're just doing the same math over and over again. And the math is basically greater than or less than, greater than or less than, or equal to. If the numbers need to be switched, it switches. If not, it moves on to the next cell. But I would gather that there's probably a better way to do it in computer science. Otherwise, you wouldn't be here, Patrick, right?
Well, there's plenty of better ways to do that. It's probably not the worst sorting method, but it's definitely not the best. Another method we've got is called insertion sorting. This also isn't the best, but it's fairly basic and easy to explain here on the show. With this one, we compare the first. We pull out values, and then we insert it where it belongs. So we have this list, 2, 1, 4, 3, the same we had before, and then we can't compare the first one to anything. So we go to second position, and we compare that. In this case, 1 is lower than 2, so we move this from the first position to the second position, and we put this 1 back in the first position. And then we've got this order, 1, 2, 4, 3. We move to the third position, and we compare that to the 2, and that's correct. So we move on to this next one. We've got 1, 2, 4, 3. We pull the 3 out and compare that to the 4. The 4 moves over, compare it to the 2. 2 is less than 3, so we insert the 3 where it belongs, and we have it in the correct order.
Right, and then there's also a combination of these two. I remember they made me learn this in college, the shell sort, which is kind of like bubble meets insertion. I'm sorry, did you ever have to do that, Lou?
A shell sort?
Yeah.
Or deal with algorithms?
Well, shell sort. Specifically a shell sort.
Oh, yeah. The shell sort, and one of the biggest ones, I think, is being able to do it. I think the insertion sort and the heap sorts are all the ones that we use the most, but I think then we have done shell sorts the best.
Yeah. Oh, how do you choose which sorts that you're going to use? And Patrick, let me throw this over to you, because this looks fine when we're dealing with very finite data sets. So you've got a couple of cards on the table. Yeah, we can understand what a bubble sort looks like. We can understand what an insertion sort looks like. But when we start dealing with huge databases, which is where this comes into play, this is why these algorithms are powerful, because we can sort huge data sets. I gotta figure that programmers need a leg up on which one they're going to program.
Well, to be honest, in most cases, I use the sorting functions that are built into the language because it's the easiest. But if I had to do something that was on such a massive scale that time made a huge difference, I would definitely research the one that would work best for the type of data I need. I'm pretty sure it wouldn't be either of these, but there's dozens and dozens of different sorting methods.
Right. And I think this is actually one of the reasons why we were a little reluctant to cover sorting. This was one of the very first topics that was suggested to us when we started Coding 101, and we kind of didn't want people to start programming customized algorithms. We wanted them to use the sort functions that were included in whatever language they were programming in. And as Patrick mentioned, and I believe Lou, you probably mentioned this as well, it's often not a good use of your resources to redefine your sort, especially since most high-level languages have an efficient sort built in. Lou, has that been your experience?
Yeah, and again, it all like Patrick pointed out, it all depends on the amount of data. So like most of these languages will have, like you said, really efficient ways to sort data of all types, whether it's large objects or small numbers. But again, once you start to get really large amounts of data sets, then sometimes it takes you to kind of combine different sorting methods or use your own to kind of come up with your own. So I think it all depends on the amount of data. And there's actually a term for that. They call it the big O notation, and we won't go into it. But basically, it's a way to determine how efficient your sorting algorithms are by how much data is in the set that you have.
Oh, well, actually, can we go into that? I am not an expert in the big O notation at all. I've heard of it, and normally I score incredibly low. But how do you judge how efficient a particular algorithm is? Because isn't that going to depend on how randomized the data is?
So yes, I mean some algorithms depend on, you know, again, type of data, but again, it's all kind of dependent on how much data you have too. So like the big O notation takes into account what we call the variable n, and n is the amount of data that's kind of in there. And then there's different versions of that. Like O to the 1 means that I can find the data and sort it very, very quickly. So it's a search and a sort algorithm that can be found very, very quickly on small sets of data. But O to the n means I need to basically travel through every element in that set to be able to sort it all out. So example is like a shell sort or something like that is O to the 1. We mean, but bubble sort would be a little bit more, it can adapt in a way so it's more O to the n. So I think there's different ways to kind of define based off the amount of data you have.
Yeah,
and again, it gets a little bit more into the math side of things.
And there would be a best case and worst case. Like a bubble sort, the best case would be O to the n, but the worst case might be O to the n squared if they were all totally reversed.
Right, exactly. And again, that's it depending on what kind of data that you are anticipating. And yes, you actually can know that based on what kind of data set you're pulling into your program. That's when you determine how long it's going to take for you to do your sort. Patrick, I know you did a lot of program for another company that we don't want to bring into this because it brings in really bad memories. But I got to think that this sort of sorting actually does come in handy when you're doing parsing of, say, employment records and such.
Yeah, any sort of record, whether you're doing employment records or skill sets or work history, maybe you want it sorted by date, or if you have a list of conventions and you want them in order by alphabetically by name or by location, maybe by zip code, who knows? But there's always something, especially if you're presenting it to the user, that you want sorted.
Right. And I'm not sure if Cranky Hippo, if you could route my screen into the TriCaster. I'm sorry, I should have brought that up before. I do want to give our audience a couple of links, a couple of resource pages where they can go, where they want to start turning this into actual code. Now, again, we're not showing you any code because, as Patrick mentioned, every language has sorting algorithms. Every language has a built-in function, and every language can be used to program the algorithm that you want. If you've got my computer, this is a decent site. This one is called sorting-algorithms.com, and this will allow you to look at different problem size sets. So how much data are you looking at? How randomized is it going to be? And then it's going to let you choose some of the different sorting algorithms that are popular, like insertion, selection, shell, merge, bubble, heap, quick. And then you can also define what kind of data you're going to start off with. And it will do a sort. It will show you exactly how it's going to work. Like, for example, this is what a shell sort would look like starting from a randomized data set. Here's what a bubble would look like from starting from a randomized data set. And again, between the two, as you can see, bubble is taking a whole heck of a lot longer than a shell sort. We can compare that against the insertion sort, which Patrick just played with, and we can see that works faster than a bubble set, but slower than a shell sort. So if you want to see these algorithms in action, this is actually a really good page to go to. Lou, I think you had another resource page, right?
Yeah, so there's, again, we kind of mulled over really quickly the Big O notation, but there's the site called bigocheatsheet.com, and it actually talks about, searching algorithms and sorting algorithms, and it gives you, it breaks down it based off of, the algorithm, the type of data structure that the data is in, and then what they call the time complexity. So like, based off of how much data is in there, the best, average, and worst case scenario in that case. And so this way you can kind of see, and then again, it has some links to some Wikipedia pages around how to implement each type of algorithm. So it gives you a better understanding. Again, it's a little bit of math heavy, but it gives you kind of a better understanding. If you look down at the bottom, there's also a complexity chart, and it shows you a better understanding of what those big O notations kind of mean. So like, for instance, O to the n means that you, between 100 elements, you run through pretty much every element in that sort. So I mean, this is kind of a good site to go to if you want to get basic understanding of the efficiency of these algorithms.
Right. I remember actually from my college days, one of the humbling experiences was when we had a course where we were designing sorting algorithms. You would optimize your algorithm for a type of data set that you were going to get, and your instructor would come by and he would just give you a completely different data set, and you would see your algorithm choke. So yeah, this is one of those things that is so easy to visualize. It's so easy to conceptualize, but in practice, different algorithms will die at different points of the data set. Patrick, any last words on sorting?
Well, researching this and reminding myself about how to do the sorting, I encountered the spaghetti sort, and I was most entertained by that. I don't know if you're familiar with that, but if you imagine yourself holding a bunch of spaghetti, and then you just put your hand on top, you can tell which one's the largest. You pull that out, put your hand on top again, you can tell which one's the next largest. And they compared it to a parallel processing sort routine, and so I thought that was pretty cool.
Oh, okay. So that's an algorithm that would work well if you had a system that could do many tasks at the same time.
Yeah, and it just says, okay, which one of you is the tallest? Boom, pull it out. Next.
All right. Well, folks, again, we are going to be including the links to the resources. We wanted this to be a foundational episode, so we're not going to be giving you any code examples beyond the one that you're going to find inside those resources pages. But we want to do this every once in a while. And the way that you're going to suggest topics is by following any of us on Twitter or in Google Plus for our know-how group, and tell us what you want to see. This was sorting. What do you want to see next? Some people would really like us to go into some advanced mathematics. Some other people want us to back up quite a bit and talk about things like, well, how do I determine whether or not I want to use an interpreted language here? These are the kind of questions that we want you to bring to Coding 101, because when we're in a module, it's very difficult for us to alter our trajectory. But when we're in this wild card arena between modules, it's all about you. Gentlemen, I want to thank you for being here for this episode of Coding 101. Of course, we're going to find both of you on the Twit TV network. You're both very involved. But Patrick, let's start with you, being our code warrior. If they want to find out more about you, about how you program, or about the other endeavors you have rolling around the internet, where do people go?
More about me, you can follow me on Twitter at @pdelahanty. More about my programming, I didn't really have a place. I programmed fancons.com, so you can check that out. It's all done by hand. And my other endeavors, I did backtothepredictions.com, where every weekday, I'm posting a prediction from Back to the Future 2 and judging if they got it right or wrong. And boy, did they get a lot wrong.
Yeah, folks, when we say that Twit TV is populated by geeks, yeah, we're not lying to you. We are a bunch of geeks. Also, special thanks to, again, our super special guest host, Mr. Lou Maresca. Lou, it is great to have you back each and every single week. This has just started as something fun, and I love talking with you each and every single week, because I'll admit, every once in a while you bring up a topic, I go, oh, I totally forgot that. I don't remember when the last time that I used X or Y or Z. Could you please tell the folks where they can find your brilliance and your work?
Sure. You can definitely catch me on Twitter at LouMM. And also all of my work that I do on my day job is crm.dynamics.com.
Fantastic. Folks, don't forget that you could always get all of our episodes. Right now, we, again, are in the wild card phase where we let people catch up. We let people catch their breath. But we just finished a programming module where we had Mark Smith, who's known as Smitty Halibut on Twitter. He's always at DEF CON. If you're a security wonk, we had him take us through an Arduino project. And it was a special project because it was a crossover with Know-How, which is our DIY maker show. It was the very first time we combined hardware and software to give you something that maybe you could make and have in your home or in your maker workshop. We're going to be doing more of those projects, but not until a future module. You could always go to twit.tv/code or Coding 101. It all goes to the same place. And there you will find our entire back catalog, along with a drop-down menu where you can subscribe to the RSS feed for Coding 101. That means you could get our episodes automatically into your device of choice. If you want the audio version in your iPhone, or the video version on your tablet, or the high-def version on your laptop or desktop, we'll do it for you because, well, we want you to learn. Also, don't forget that you can find me on Twitter. That's twitter.com/PadreSJ. That's at PadreSJ. I will always include what we're going to be doing each week so that you can see whether or not you want to tune in. I'll also give you an opportunity to suggest guests. I've actually received many possibilities, potentials of guests from this Twitter account and also from our Google Plus group, and hopefully we'll have them on in future modules. Now, speaking of Google Plus, don't forget to go to Google Plus and search for the Coding 101G Plus group. It's 2,000 members strong and growing, or actually, no, that's a very old number. And it's filled with people who are beginners, intermediate, and advanced. It's a wonderful community to go to if you've got questions, if you've got answers, or if you just want ideas for projects. Finally, don't forget that we do the show live. We now do it on Mondays, normally, not right now, but this would have been live on Mondays at 2:30 p.m. Pacific. Drop by at live.twit.tv and watch how the sausage is made. And as long as you're watching live, drop into our chat room at irc.twit.tv so you can talk with the hosts and the guests. You've got you right up there while the show is going on. Thanks to everyone who makes this show possible. Of course, to Leo and to Lisa for letting us do it, for all the engineers here at Twit TV, and of course, to my super special TD. I like the super special. It's one of the things I do. Mr. Brian Burnett, he's the cranky hippo. He's the man who pushes the buttons and who makes it possible for us to do this. Brian, could you tell the folks at home where they might find you?
Well, I would have a camera, but I had to do a last switcheroo there to get your laptop. But you know what? You can find me and Padre doing Know-How on Thursdays at 11 o'clock. And do you watch that show at all, Patrick?
I've been on that show a couple times too.
Oh, that's right. But yeah, we have a lot of fun doing that, and you can follow me at cranky_hippo. I also do BYB reviews, and now we're doing that show together.
Until next time, folks, I'm Father Robert Ballister, and from the entire Twit TV production staff, we say,
and